So, we did A, B, and C yesterday, and we're starting off with an example on D. So, someone want to explain how to do this? Okay, first of all, how do you do this and how do you know how you do this?
So what I did, I took from the limits of 5 to 1, after the x, subtracted 2 to 1, so 5 to 2, and 2 is the upper bound, the upper is over there.
Okay, so you're saying in order to get from 5 to 2, all right? In order to get from 5 to 2, I need to do what? I need to take from 5 to 1.
Subtract 2, because 2 to 1 is
Right. And I need f of x, and you're correct, and I need to subtract from 2 to 1, which would be, and what are these values? 6 minus -4, which would be 10, you're saying. I like it. Can you guys see another way to do this? There's actually another way that requires 2 of the rules I just showed you. Yes, and then you add them. When you flip and negate and add, it's the same thing as negating a negative. Do you follow what I'm saying? Yes. That's it. Let me give you a visual of this problem first. All right? 0, 1, 2, 3, 4, 5. From 1 to 2 is negative. So from 1 to 2, it's below. Right? From 2 to 5, it's above, like that, right? So they want us to figure out the area from here, 5 to 2, from here to here. So I take this total area from here to here, or excuse me, I'm sorry, it starts at 1, doesn't it? We have from 1 to 2, which is from here to here. And then we have from 1 to 5, from here to here. So I take from 1 to 5, which is 6, and I subtract this. I take this away. Subtract what that value is, and I get 10. Okay? You see what I'm saying? So there's actually another way to do this. Instead of doing it this way, we could use additivity. We could use additivity number 5. Which means if the top and bottom match, I can just go straight from C to A. All right? I go straight from C to A. But as I'm looking at this, yeah, no, I can't. I make 2 and 1, and no, I think I'd have to do it this way. How come? If I went from 5 to 1, that's this one right here, I get 6, right? Then I'd also, instead of going from 2 to 1, I'd have to go from 1 to 2, wouldn't I? I'd have to flip these. But what happens when I flip? Don't I negate what that value is? So instead of being a -4, I would negate a -4, which is a +4. And additivity means you add them, right? But that brings you from 5 to 1, not 5 to 2. But I get the same answer. Which I would have to look into this and make sure. I'm very confident this is right. Is it just a coincidence that this matches? You see what I'm saying? No, it does work. Because what happens? If these two match, I can cross these out, and it's like going directly from here to here, which is what this does, and they both give you 10. If that's confusing, just remember what we did in blue when I showed you the picture. I'm just trying to take it to the next level for those of you that can follow. Okay? Get it? Get it? Understand? An extra sheet? Sure. What about E? E. What do I need to do for E? Yes. This rule is the same as our sum of difference rule. Okay? I can take it individually, so add or subtract. So I can take f of x from 5 to 1, which is 6, and I can subtract g of x from 5 to 1 still, which is, very good, new one. Low and easy. It's the combination. The same thing we just did. We can actually use E to do F. Well, F, yeah, right. F from 5 to 1 is still 6, but I'm multiplying it times 4. G of X from 5 to 1 is still 8. 4 times 6. Minus 8. Bam, perfect. It doesn't get much work for today's lesson. Yeah, we can go over that after. We can do it off that second. Okay? So there we go, not bad. Let's step it up. And when I say step it up, I mean we're just adding one thing, literally. Okay? The average value. So let's say I find the area under the curve. Well, what's the average area under the curve? Instead of adding it all up from one point to another point, because it's going to different. It's going to be different, right? It's going to. All right. Thank you. But it's going to be different. So if I took all the areas for each thing and averaged them, what would it be? This helps you do this. How do I find that average value? Well, I take the area under the curve and I divide it by the width. That's it. I do the same thing we're doing, and I just divide it by the width.
So the whole width or some of it?
No, the whole width. Ready? Whatever this is, if I have an interval from B to A, for that area under the curve, I just divide it by whatever B minus A is, that width. Now, they multiply it by 1 over B minus A. That's the same thing if you'd rather do it this way. If you'd rather take this from B to A of your function and divide it by B minus A, that's the same thing. Okay? So, let me show you with numbers. Once I show people with numbers, they kind of like, oh, that makes more sense. Sometimes letters and variables throw everybody off. So, okay, make sure you have this written down in your notes. All right, so now here we go. The graph to the right corresponds to this right here. 1/2 x squared from 3 to 0. Well, let's use the constant rule to make this real easy. Let's pull that 1/2 out front. Okay? So that's the same thing as saying 1/2 times the integration from 3 to 0 of x squared. Okay? What is the integration of x squared? What are my steps? I add 1 to the exponent first, then I divide by that. It's x cubed over 3. It's x cubed because I add 1 to here first, then I divide by that new exponent. From 3 to 0. Now let's not forget, I still got to take this whole thing and multiply by 1/2. That is going to give me this. Okay? So, you'll notice with 1/2 out, it's going to be a little easier. If I put a 3 in here, that's 3 cubed, which is 27 over 3. Minus 0 cubed over 3. Now what do we have? That is 27 over 3 minus 0 over 3, which is 9 minus 0, which is 9. But I still, I can't just forget that. Which you have to equal 4.5. Okay? So that's the area under the curve. But what if I want the average? What's the width of my intervals from here to here? It's 3. What? You see what I'm doing? I'm still going to multiply my 9 by 1/2, which is 9/2. Okay? And I just, well, 9/2 is the total, but how about if I want to find individual, the average? We'll just divide it by the total width. If I have 15 tests in here, and you guys all score differently, but I want to find the average, I just take those scores and divide them by 15. I take this and divide it by 3, don't I? Yeah. So I can either, if I divide this by 3, or divide this by 3. It's easier to do this, but this is, you know, the kit and caboodle. Or what's another easier way to deal with a fraction? Instead of dividing this by 3, what can I do? Multiply it by 1/3. Yeah, that would be easier, wouldn't it? So 9/2 times 1/3 is 9/6, which is 1.5, which is exactly what you get if you do this. 1.5. This equals 3/2. It's the same thing, depending on whether you go fraction or decimal. So you still take the area of the curve, just divide it by whatever your width is, where you start and where you end. Okay? So here's the average. If this was a rectangle, if I were to take all this area and make a rectangle with it, this is what it would be, 3 by 1.5. Okay? No, they might give you 2 lines and say the area between the curves. It's not just under one curve, but under one and above the other. It's crazy. Love it. Maybe. Yes. I did both. All right, so the mean value theorem. All right, for definite integrals. The mean value theorem for derivatives. I'm going to review this first. The mean value for derivatives said, if I had, now this is the mean value theorem for derivatives. You don't have to write this down, you're just going to follow. Okay? If I had a point here, this is at 0, 0, right? And I took a point here. This was at 3, 2. Okay? And I did some line going like this. Like that. The derivative, which means slope, changes constantly, doesn't it? Yeah. Well, at some point between here and here, the slope on this function has to be the same as the slope from here to here, right? Like if I took the slope of 3/2 and 0/0, and I did change the y over change the x, I get 3. I get what, 2/3? I get 2/3, which equals up 2/3, right? No. Yeah. Oh. 2/3 is up 2/3. So up 2/3. So somewhere on this graph, there's a tangent line right here at this point. Right here, this point down here. Wow, look at that. Right here, come on, wiggle. Boom. So yeah, there are several points. So somewhere it has to be that. Guess what the mean value theorem for integrals is? Out of all the area under this curve here, if I take the average of it, at some point, yeah, there's going to be some point where the area under that point is equal to your average. So look at right here. If I take the area under this point right here, that's 1.5. There you go. You just got to understand it. Okay? All right. That's it. That's it.